Let's continue learning NumPy. In the previous video, I showed you how you can create arrays like this using code like this. We had to write this much of code manually because we wanted to understand how arrays work, how 1D, 2D, 3D array work. But now that we know how 2D, 3D arrays work, we can write this much of code just to create the same array, or maybe like this. That's what I'm going to talk about in this video. Let's get started. I've created a new notebook but essentially pasted in the same code, the code that created three-dimensional array. In this array, if I look for the shape is 323, right? 323 means that the array contains three elements. Now, all these three elements by themselves are again 2 by 3 arrays, which means 2 rows and 3 elements. Similar to shape, we have one very interesting method, but before that, just create a range. I have to go up to 19 because the last number is skipped, right? And then np.array, and if I pass it, we get up to 18, 1 to 18. What I can do is, I can call a method called reshape. This reshape is very interesting method. What you can do is you can change the shape. What shape do you want? You write it here. For example, let's say that I want this array to be converted into a two-dimensional array of 6 rows and 3 columns. There we go. We have an array which has 6 rows and 3 columns. Or I can do the other way around. Make sense? As long as the total number of elements stay the same. Here, the total number of elements were 18, right? This multiplication should be 18. If I try to do it else, it will not work, which is obvious, right? You can't do that. Similarly, if I want to convert this into a three-dimensional array of 3 to 3, I can do that. Very simple. This is the fastest way to create a three-dimensional array. This reshape method is very simple, but it is actually going to be very interesting, very useful when you're working with real life data. When you're working with real life data, you have to clean up the data, you have to adjust the data as per your requirement. And this is where this reshape method can be really, really useful. All right, let's move on to the next one. And this method is called Arange. Okay, don't read it as arrange, it's Arange, because this is going to create an array. Right? Of course, whatever you could do with range, you can do with Arange. For example, let's say that I want to create an array of even numbers. I can do that. It starts with 2, goes 21 minus 1. It will not touch 21 and it will jump 2 every time. And of course, if you want floats, you can use floats as well. Let's see. Let's say that I want to start with 0.1. I want to go up to 1. But it's very essential that if I just execute it directly, I'm just going to get 0.1. That is not what I want. What I want is in the increment of 0.1. I can get this one as well. If I put it 1.1, I will get exactly these 10 values. Similarly, if I start with 1 and if I say, let's say 3.1, then it is going to create, I don't know, I will have to count, right? There is no control over how many numbers have been created, but you want control over how many number of items are there, right? And for that, we have another interesting method called Linspace. Linspace is actually short for linear spaced. What is linear spacing? Basically, everything is spaced equally. For example, if I say that I want 1 to 10, if I just run it, it's going to give me all the numbers possible between 1 to 10, but I can limit it. That let's say that I want exactly 10 numbers. Starting from, let's say, 4 to 10, I want 10 numbers. There are a couple of key differences between Arange and Linspace. Number one, the last item, the second number is included. I have given 4 to 10. Both 4 and 10 will be returned. Number two, the most important difference why you actually need Linspace is because you control exactly how many number of items you want, and increment is that it calculates automatically. But in Arange, you give the increment, right? I want every number to be incremented by 0.1, but how many numbers are going to be returned? That is up to Arange. And here the thing is reverse. You control how many number of elements you want. This may not very big deal, but let me show you one interesting example. Before I can show you very interesting use of Linspace, let me show you one small thing. This one is np.py. If you execute np.py, this will simply give you the value of pi. This can be very useful. For example, let's say that I want to create 100 numbers, okay? I want to create 100 numbers. What should be the starting point? 0. And what should be the ending point? np.py into 2. Again, what I've done here, I've created an array that has 100 numbers, starts with 0 and goes to 2 pi. If I probably write like this, it will be more obvious. This I have stored in X. Let me create another variable. Here I am going to call another interesting method, and this is sine. Okay, if I just write like this is going to print numbers like this. Again, because I'm sending 100 numbers, it will be 100. Store this in Y. What I can do is I can use matplotlib. I'm using a virtual environment and matplotlib is not even installed. Let's install it. Pip install. The trick here is if you use an exclamation mark, you can directly run shell command. Let's see. It is installed. Let me just delete this cell and import it again. This time it is imported. Let's plot these numbers using matplotlib. plt.plot x and y. And there you go. You have created a sine wave. If you're not familiar with matplotlib, don't worry. One video will be dedicated to matplotlib coming. But for just know that matplotlib is very simple library which you can use to create quick plots like this. Let's move on to our next function. The question is, can we do this using range or Arange? Probably yes. Let's try that. Instead of Linspace, if I try Arange, I'll have to go from 0 to npi. This is fine. But the problem is determining what will be the appropriate number. If I say 0.5, no, this is not good enough. If I try 0.25, I'll have to go 2, 3, whatever. No, not good enough. If I try 15, still, okay, the numbers look big enough. And probably if I use this to plot, the plot is going to be smooth. Probably. Because let's check the length of this. 63. Not enough, right? The problem with range or Arange is that you can't control how many number of items are returned. Is there another way to create arrays? Of course there is. Let's see. The fastest one is np dot. Let's say that I want to create one array very quickly. I can call np.empty and I can give it the length that I want it to be. What empty does, it allocates memory, and whatever is written in the memory, it is not going to reset. Whatever is there in the memory, it will just simply show up. And it can be useful only if you want to create a huge array. Let's say that I want to create an array with length of 100,000. This is going to be my fastest way to create an array, right? Because it has simply allocated memory for 100,000, but the values are going to be junk. Whatever is there in the memory, all those values will stay the same. There are two more interesting methods. np.ones. Let's say that I want an array that has 15 length and everything should be set to 1. And of course, if there is a ones method, there is a zeros method as well. np.zeros, and let's say 10, and it will create an array where everything is 0. You might have noticed that this is all allocated as float, and if I want to change that, there is another optional parameter, d type that you want, the data type that you want. Let's say that I want integers. I can just pass int, or I can pass d type equals, so it is either np.16, np.int64, like that, right? Here we see that this is int 16. Let's talk about creating arrays with random numbers. There is a convenient module called random, and from this let's try integers. Rand int. This is a very interesting function. If I press Shift Tab, Jupyter Notebook will immediately give the tooltip. We can provide low, high, and size. Right? For example, I want random numbers between 1 to 10. That's it. If I just execute just like this, it is going to return one random number every time I execute it. Give me an array with 5 numbers and choose the numbers between 1 to 10 or 1 to 100, whatever you want. The interesting thing is this last parameter. This parameter is actually, it is actually a tuple. What is the benefit of using a tuple? That you can create, let's say, 2 by 3 matrix directly. 3 by 2 by 3 you can create. Whatever shape you give as the third parameter, it is going to create. But there is a but. But if you're working on a newer code, this method is actually not recommended. The better way is to use a generator object np.random, and let's get the default generator. Okay, this is going to return you a generator. Let's store it. First, let's try to create uniform array of, let's say, between 1 to 10, the same thing that we were doing, and we want the length to be 5. This is going to return an array with length 5 and all the numbers between 1 to 10 uniformly distributed. Last parameter is again, it can be a tuple. Whatever shape we want, we can create using this. If you want to create a 4-dimensional array, you can create just like that, right? Very interesting. Let's stick to a 3-dimensional array, which is still readable. Similar to uniform, we have normal distribution. For example, the same one I can create using, let's say, 3, 2, 3, and I missed a bracket. This time, instead of uniform, it is using normal distribution. What is uniform distribution, normal distribution, binomial distribution? If you want to understand all these topics, I can create a video for you. If you're interested, let me know in the comments. Moving on, let's say that instead of all these floats, I want integers. That is possible. All we do is let's call r.integers method. And again, we are going to choose a starting point, an ending point, and how many number of elements we want. I want 4, or perhaps I want 3 by 2 by 3. Same thing. But this time, everything will be returned as integers. What about booleans? Booleans, actually, there is no direct method, but we can use another interesting method called choice. What choice allows us to control, for example, let's say that I want only true or false. These are my choices. And of course, these choices have to be a tuple or a list. And I want a length of 5. As you can see, it is created an array of length 5 using only these values. Does this have to be only true or false? No, it can be anything that you want. This video is intentionally a short video. You let me know in the comments whether you like this kind of short videos or would you prefer to cover a lot of topics in one single video. Do let me know in the comments. Your comments are really, really useful. See you in the next one.